welcome to example A from 6.2. And we're going to write each expression in exponential form. So we want to be able to do this repeated multiplication. Notice how all these numbers are the same, so I can actually write it as an exponent. So I have to count up just how many there are. So how many times am I multiplying the 5's together? 1, 2, 3, 4, 5, 6. So for part A, we have 5 to the 6th. There we go. For part B, well, I have 1, 2 3's, and all the rest are 2's. So it means I can say 3 squared, and because the 2's are different, they kind of become their own base. So that's what the number that we're multiplying over and over again, that's the 3 is the base, like 5 was the base for A. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So this would be 3 to the 2nd times, oops, there we go, times 2 to the 9th. Wow, this is not doing so well here. There we go. 3 to the 2nd times 2 to the 9th. Alright, and then part C. The current balance of a savings account was opened 7 years ago with $200, earning 2.5 interest per year. Okay, so if you remember from 6.1, the assignment that we did the other day, we found out that if you want to do an increase in 2.5%, that increase in 2.5% is you get 100% plus the 2.5%, which is 0.025, right? So we're going to be taking 200, and I think I can kind of write it over here. We're taking 200, and we're going to be multiplying it by, multiplying it by 1.025 7 times, right? So it's going to be 1.025 times 1.025. That's not really going all that well at all. Okay, and then I can keep on going. I'm just running out of room, so I'm just going to write dot, dot, dot. Because there's a faster way to write this, right? So I can say this would be the same as 200. I'm multiplying this 7 times, right? So it's going to be 1.025 to the 7th, right? Because I'm multiplying this 7 times. So it would be 200 times 1.025 to the 7th. And there you go. There's example A. Let's move on to example B. So example B, right here, says Seth deposits $200 in a savings account. The account pays 5% annual interest. Assuming that he makes no more deposits and no withdrawals, calculate his new balance after 10 years. Alright, so what we're going to do is we're going to write this in expanded form. So what I just did here is I put in how much he starts with and what is the balance going to be after 1 year, what's the balance going to be after 2 years, 3 years, and then X years. And then we're going to write in expanded form, exponential form, and what is the actual balance after each one. That way we can kind of probably get to 10 whenever we want to. Okay, so his starting value is 200, right? Exponential form, that's just 200, and his new balance will be 200. It's not really any different, it's just that's how much it was to start with, and that's how much it's going to stay. Alright, so next we're going to do 1 year. So expanded form means that how much is he going to increase his money? Well, he's increasing by 5%. So we're going to start off, he gets all 200 back, and he's going to say this is going to be 1 plus 0, and we'll say 0.05, right? Because he just added 5%, so we could go ahead and do that whole thing. If I write this in exponential form, that's going to be 200 times 1.05, and how many times am I multiplying 1.05? Just 1 time. Okay? And I should get exactly, I should get exactly $210. I'm going to make sure that I can keep this separate, so I'm actually going to draw a line with them. So we're just going to go ahead and just keep this here, that way I know that okay, and then I'll put one for here, because otherwise I know that I'll start to mess this up a little bit, and I want to try and be as organized as possible. There we go. So after 2 years, in expanded form, what we're going to do is this would be 200 times 1 plus 0.05, and we're going to have to multiply that again by 1 plus 0.05. Okay, and if I want to write that in expanded form, well, it's going to be still 200, and I'm going to have 1.05. 2, how many times am I multiplying together? 2. And when I do that, I get $220 and 50 cents. Alright, so after 3 years, we're going to do the same thing. We have 200 times 1. Instead of writing 1 plus 0.05, I'm just going to write 1.05 times 1.05 times 1.05. If I want to write that in exponential form, it's just going to be 200 times 1.05 cubed, right? And that's 231.53. 231.53. Oh, okay, that is a 3. Yes, it is. There we go. Okay, so after any number of years, x years, my expanded form would be 200 times 1.05. That's a strange looking 5. 1.05. Computer's not helping me again. Times 1.05. Really doesn't like me. And I'm just going to put 3 dots because I would like to put 3 dots if the computer would let me, if it liked my drawing. So it'd be 3 dots. It means it's going to continue on this track x years. We don't know how many x is, so I can't just keep on putting them in. But you have enough to say, I understand the pattern. 1.05, 1.05, 1.05. All right, so if I want to do this same thing, it'd be 200 times 1.05 to the x. Okay, and I don't know what that new balance is going to be because I don't have a number for x, so it kind of depends on the number of years. Okay, but what I'm going to do is, well, we'll put it up here. For 10 years, because that's what we're trying to do to answer this question. Okay, you see that I'm writing this down, right? But it's not really letting me do it. Okay, I'm just going to try again because that looked like yeefs. 10 years. Doesn't like me to do R's, I guess. Okay, so after 10 years, all we have to do really is I can put this right in exponential form and do 200 times 1.05 to the x. And what is that? Type it in your calculator now. So it should be 200 times 1.05 to the 10th. And you should get, write it here, 325.78. So that's how much the account will be. Alright, so last thing we're going to do is let's just talk about exponential growth. So amounts that increase by a constant percent, like that savings account problem, have something called exponential growth. So that means obviously it's growing because it's increasing. So you can say, I know it's increasing, I know it's going to grow. Those two words seem to make sense together. And exponential because it's increasing by a percent, so it's not going to be linear. It's a non-linear graph. So any constant percent growth, so notice how the percent is constant, not how much money you're increasing, but how much what is the percent? The percent is going to be constant. So any constant percent growth can be modeled by the exponential equation y equals a, parentheses, 1 plus r to the x, where a is the starting value, r is the rate growth written as a positive decimal or fraction, and x is the number of time periods elapsed, and y is the final value. So what we could do is we could set up one just for that last problem. We could say how much money did he have, right, the final amount of money, if, what was the guy's name? Seth. If he started off with $200, right, so 200 was my A, and then it was 1 plus R. Well, what was the rate that he had? Well, the rate was 5%. Notice how we wrote 1 plus 0.05. So it's got to be 1 plus 0.05, and then it says to the x. So if we head to the x, in this case, our x was 10 years. So we just plug in 10. Okay? And there we go. So we just plug that in. So exponential growth. You have 100% plus the extra percentage or fraction, whatever you have that's included in the problem. And then we have to figure out what this is to find out what y is. Okay? So there you go. There's a good explanation of the examples A and B from section 6.2.